So welcome, everyone. I hope you've been enjoying the talk so far, although Ben did take some of our time. But that's OK. I'm not worried about that much. But what we'll be going to talking about is keeping an eye on your serverless container. Now, there's a lot of buzzwords in there. I wanted to throw another one called observability, then Arjen hold my hand back. But that's pretty much what we are going to talk about it. But what we want to do is, in this session together, we will try to brainstorm a solution for our billion-dollar idea. And doing that, we might highlight some key points around serverless containers and how do you go on doing observability around it. But before we get into that, let's us just introduce ourselves. So I am Prateek Nayak, one of the lead engineers at Innablr, which is based out of Melbourne. I am also one of the co-organizers for the Melbourne Kubernetes user group. Have been working in various cloud environments and Kubernetes for the past few years. And if you want, you can follow me on Twitter there.
Cool. And I'm Arjen Schwarz. I'm a lead platform engineer at DigIO, which Ben probably already introduced, so no need for that. I'm also an AWS APN ambassador, which basically means I talk too much about anything AWS. Case in point is that I help organize the AWS user group. And when I'm not talking about things, I write things on my blog, ignore me, go check it out, or follow me on Twitter, GitHub. The handle is there.
Seriously talks a lot. Anyway. Sorry, that was inner voice. But I think something else we need to introduce today is our billion-dollar idea. So that's the whole pitch we are going through in this talk. We'll try to introduce an idea, try to build a serverless solution, and try to talk through how do we do observability around it. So I think over the weekend while drinking, we were talking about this. Sorry, I wasn't supposed to say drinking, but we were talking about this whole serverless craze that is going around. Like, everybody wants to do serverless. Nobody wants to manage infrastructure. And we just thought about what will happen to all the servers. And then we came up with a billion-dollar idea, didn't we?
We did. Because think about it. We've had these servers for years or decades. We've kept them as pets. And now you're just going to throw them away for a little Lambda function? Where's the fun in that? That doesn't show your appreciation for all the hard work these servers have done for you, for all they've done. You loved them, you cared for them. So what we came up is a retirement home for your servers. Your servers can come here to our place. We're still building it. Any VC funders, please talk to us afterwards. But we'll have special rooms for them, whether it's a dark cellar somewhere or a bright place for those servers that enjoy Windows. Anything you want, anything they want, field trips to famous data centers, anything.
Yeah.
We'll try to take care of them for you.
Yeah, think of it as a retirement home where you can feed them, water them through an API. And it says the website is cuddlecube.com. It has no relationship with Kubernetes. Just to be very clear, I'm one of the co-organizers of a meetup. I will never diss on Kube. Anyway, it's called cuddlecube.com. And as Arjen said, there are certain requirements which are non-technical, that we need the ability to feed them. We need the ability to register our new service. But what we'll focus on today is brainstorming the public site aspect of this new retirement home for servers. And I do have certain requirements. And we've gone through some of the beautiful talks this morning. And some of my requirements are, I'm a container fanatic, and I love this whole idea of microservices. Even, we don't know how to do microservices. I love them. So one of my primary requirements is we want microservices. Microservices everywhere. Build nano services out of them. I want containers because, hey, this is a container conference, so we want containers. And I love containers, to be honest. But the most important thing for me is, and I think I've had a little bit of this serverless Kool-Aid as well, I do not want to run any infrastructure. I do not want to be managing nodes and have issues like people DDoSing our serverless or our serverful infrastructure in the live audience.
That's not an invitation, by the way, to DDoS CuddleCube.
Please, do not. Away from the laptops, from there. I know a few people from there DDoS the living hell out of the other app. But so my primary requirement, I do not want to do any infrastructure, Arjen, because we're building a home for infrastructure. What do we do?
Exactly. So, well, as you know very well, it's not new anymore, but there are serverless containers these days. So serverless containers allow you to run containers without the infrastructure. So in case you're not completely familiar with it, I know you are, but maybe some people in the audience are not. let's take a step back and look at, okay, a long time ago, we had our old faithful servers, the ones that we now want to send to a retirement home to live long and happy lives after. But they were not fun to manage. Yet, maybe you had to go to data centers in person. Nobody wants that. So that got improved when we had VMs, or as we call them in the AWS cloud, at least instances, where you don't have to care so much anymore about the underlying hardware. And then, of course, the better improvement on top of that is we got containers running on all of that, and this gives us all the freedom we want. We can focus just on things, on our applications. So, but like I said, in the cloud, you already had the abstraction away from the servers, so we only care about the instances and the containers running on them. But serverless containers take even that part away, so we just have the containers. Or, as I like to think of it, we have our containers floating in space. These containers are just up there somewhere. Who knows? They might magically have some hardware underneath that I don't know about. I don't care.
Just that image in itself shows that you are drinking this serverless Kool-Aid, aren't you?
I am.
Space containers, people. Space containers. Anyway, this sounds very good. So if we overlay our problem on top of, overlay these serverless containers on top of our problem and come up with this high-level requirement that we need a way to register servers, feed them, and list all of them, I think we can pretty much draw up our architecture, can we not?
Yeah, we can.
So let's have a look at what we came up with. So this is our current solution. All of these APIs, all of this, so there's a public website where you can hop on and start registering your service. It is exposed by a load balancer in the cloud, which is, again, we don't have to manage. All of these are Golang-based APIs, which are containerized and are running as space containers or serverless containers, whatever you want to call them. But then there is an element of database. As soon as you start talking databases, because it's very hard to make them serverless. And we were thinking about it, and again, as Arjen is always AWS, and he's like, oh, let's use DynamoDB, which works out fine for us. We don't have to look after anything. It scales on demand, and all that beautiful bells and whistles. So this is our end state architecture, where we are using AWS Fargate. And by the way, as Arjen said, it's not just AWS. You can pretty much use any cloud provider today which has these offerings, and most of them do. Except for a few which are not actually clouds. But anyway, so on AWS, you can leverage AWS Fargate for your serverless container offering. You can leverage DynamoDB and the load balancer. So this is what our architecture looks like. But I know most of you here can spot a tiny problem. I've been banging on about observability so far, but in that architecture, the biggest problem, or for me initially it was, because I come from the Kubernetes world, where as soon as I want to look at something, I can just kubectl logs or Docker logs. I don't have that in this scenario. How do I run my monitoring suite or my observability suite like Prometheus, Jaegers, Grafana's, all of those? How do I debug those teething networking issues? Because I know whenever we had an Istio mesh deployed on our Kubernetes cluster, you had to hop onto the box, fire up TCP dump everywhere, and look at the packets and see what's happening. And at the end, you will figure out, oh, there was some IP tables rule, just IP table flush, and it works. How do I SSH, and how do I work with these?
Oh, Prateek, not the SSH thing again. We're talking about observability. You don't SSH. If you have to SSH, you already failed. But aside from that, you do make some good points. How do we get the logs? But what you're doing here is talking about specific tools. Why don't we take a step back and instead of focusing on specific tools, look at what you want to achieve with your observability. And then from there, we can work out what tools might work.
You make a very good point, Arjen. And I think as engineers, we sometimes do dwell on the tools a lot. We don't focus on the what and what we're trying to achieve and what we're trying to do. So let's take a step back and start defining some of the constructs in terms of observability rather than saying I need Prometheus or I need Grafana. So what is observability? I'm pretty sure most of us are across it, but I'll still cover it so that have a baseline of what we mean by it. Observability in a nutshell is it's an attribute of your system where you can understand the state of your system or pinpoint where the error or performance problems are occurring without having to RDP anywhere, SSH anywhere, or poke any API. You should be able to observe it from the outside. And the other facet or the other facade of observability is that in traditional systems, we had monitoring for a while, we had logging for a while, and we've been doing beautiful jobs. We've progressed a lot from the Nagios days of up and down checks to now collecting meaningful metrics. But still, just monitoring and logging are very isolated and application specific. We don't get the end-to-end user view. We don't get to see or don't get to diagnose where the user is having a bad experience. So that's what observability is. And I think we can break it down into 3 main constructs. And most of you who see this image will be going, hello, there is monitoring and logging in there, and you were just talking shit about it. I wasn't. What I'm trying to say is observability defines some good rules and constraints around our existing terminologies like logging, monitoring, and it adds another pillar, which is called tracing. Together, these 3 form the observability suite and can provide you the insights you need to debug or diagnose your applications. Yes?
Yeah, that makes perfect sense. But so can you go a bit deeper into these 3 pillars so we can find out what we might be able to use?
Glad you asked. Not that we've practiced this before, but anyway. So let's start by each pillar. And bear in mind, we're not talking about the tools here. We're talking about the concepts, because what we will do at the end of the day, take these concepts and translate them to this new serverless world. Because for me, when I started on this journey, it was very interesting that how can I translate some of the tools that I need infrastructure to run on into this serverless world. So let's define what logging is. And I'm not redefining something. I'm just reiterating and trying to be very specific. Logging is just a record of your timestamp record of your events that occurred in your application. Yeah? What we do forget about logging is it's information that is required for conducting forensics. So when you have a hunch, okay, there's an issue in this application, logging is absolutely useful in that scenario. You can go into the logs and see what your application did. Was there an exception? Was there an error? What was the problem? Yeah? It's not about the tool. It's about what you do, what this defines. And then after logging, we look at monitoring. What is monitoring? Monitoring is not just looking at up and down checks on your application, because, come on, that doesn't really serve any purpose. And it's not about just measuring your CPUs and memories, because, again, it doesn't serve any purpose these days. But what it means is actionable metrics around your user experience. But again, unfortunately, with monitoring, it's isolated to an application. Yes, you can, once you have identified that this application is the problem, you can go and look at your monitoring and your logging and get more insights into it. But again, logging and monitoring alone do not offer you that, you can't pinpoint where the error is. And this is where the 3rd pillar comes into play. Distributed tracing. Distributed tracing is pretty much you profile or monitor your microservices via request tracing. Now, what does that mean? Whole bunch of mumbo jumbo, but what does that mean? So if, let's say, you have 10 microservices in your application suite, and your user has to go through each microservice or each API, then how do you pinpoint where the user experience went bad? This is what you achieve via distributed tracing. You monitor, you capture metrics around that request, all from the first to the end API, aggregate them in a centralized location, and get a view of all the traces. Yeah? With me so far? Anybody lost? That's okay. Nobody's lost. And last but not the least, we can pinpoint the failure points. Yeah?
Yeah. So what would you say are the key points for implementing this? How do we?
That's a good question as well. Again, if I had my infrastructure hat on and I was like, yeah, I have a bunch of EC2 instance available to do something, I would have said, yeah, install this product, install this product, install this product, and you should have observability. But now we're going serverless. So let's take a step back and define what are the components, or what are the terms that we need to get our observability sorted. So first thing and the foremost and the most important is instrumentation. What do I mean by instrumentation? So if you have 10 or 15 microservices, they're not automatically going to generate this data You have to write some code. You have to instrument these codes, these apps with some code so that they can generate telemetry. And then once they are generating this telemetry, you need to collect them somewhere. You need to ingest them, analyze them, aggregate them. And third, and which is the most important one, is you need a way to expose them. Like visualization and interrogation of these telemetry data. What's the frickin' point of collecting all this telemetry if you're not going to look at it? If they're only going to be sitting on a server in a log file, what's the frickin' point? Yeah? So if we take a step back from tools, this is how I see observability can be implemented. But there's always a but. The but is, as I said, instrumentation. Today, in our solution, as you saw in the architectural diagram, we had 6 or 7 microservices, yeah? It's fairly easy. I can write the code. And actually, it's super easy to just copy and paste and forget about it. But when CuddleCube scales to hundreds or thousands of microservices, what will happen then? I would need to instrument each and single application. I would need to provide a means of transporting this telemetry for each and single application. I would need to host a server which can collect metrics from all of these applications. Last but not the least, I would need to manage my third-party dependencies in every application, which are not part of my business logic at all. They're third-party. I would need to track them across all the application suite, which for me is slightly problematic, and I don't want to do with CuddleCube. It's my CuddleCube.
It's your CuddleCube. It's our CuddleCube. Thank you very much.
Sorry.
But look, these are not new issues. We've been running into these kinds of issues for years, and there are solutions for that, aren't there? So how would you solve this in your beloved Kubernetes clusters?
Oh, Kubernetes, easy peasy. Service meshes. Everybody knows service meshes, and I think there's a talk today about service meshes as well. So if I had my way, and if I had my clusters, Kubernetes clusters, I would just have dropped Istio or Linkerd or any other service mesh, and all my apps would have been instrumented. I would have got Envoy proxies alongside my apps, collecting all of this data. I would have got Jaeger, Prometheus, Grafana, anyway. But the constraint that you put on me, serverless contains, where do I install my service mesh?
Cool. So in this case,
don't tell me you have some magic for me.
Well, I don't. But as we are using AWS, and without trying to make it sound like a marketing spiel for them, there is a service called AppMesh, which is basically a serverless service mesh. And just try saying that several times fast. But this should allow us to basically do the exact same thing. So let me just walk you through how it works so that you can tell me whether that is the case or not.
First space containers, now serverless service mesh. What are you smoking, man?
I'm smoking the Kool-Aid. So as with other service mesh, what we basically have at the front a virtual service, something that is the endpoint where your applications talk against, whether it's a load balancer or an internal microservice. It all goes to the virtual service. This virtual service, of course, has then a virtual router underneath it. This router basically says, okay, if I get hit in this way, then go there. Now, at the moment, AppMesh is very new. So new, shine hasn't gone off yet. But that means it's a bit limited so far. You can't do a lot of the fancy routing rules that the more advanced Kubernetes ones have. But for our case, it does have everything we need. You can just do path-based routing for, hey, if you hit this path, go there, things like that.
Okay.
And based on the path-based routing, you will then have the virtual nodes, basically, that are the service app mesh's representation of your underlying infrastructure. So what happens there is I hit my slash endpoint, and it goes to the virtual node without a name at the top. And that virtual node then has, through service discovery and all magic means, will know where to actually send the request.
Okay.
And of course, in turn, these can then talk to the next virtual service and so on and so forth.
I think this definitely looks like a service mesh because this is the idea of the service mesh, yes? Like you have interconnected services where you can do service discovery automatically and get all the goodness out of it. But how do you still do the telemetry aspect of it? Can we do that?
So let's look a bit deeper then into how this looks. So if we have a task, if you're not familiar with the AWS definitions, is basically what you run, and it can have one or multiple containers inside. So in this case, we have in the middle there specific tasks that the microservice that we're running. So a public site on one end and the list on the other. On top of that is an Envoy sidecar, which is something you're very familiar with from all the other service meshes. It all works the same way. It's a proxy. Any traffic that comes out of the public site goes through the Envoy. Anything that comes in goes through the Envoy.
Okay.
And the Envoy then gets updated by way of the app mesh, which tells it, okay, you can do this, you can do that, but you can't go there. And if you go here, you do it this way. It's basically how the service meshes that you're familiar with work.
Absolutely.
Yeah. So the other thing that I already sneakily put in here is for your tracing. So you're familiar with the AWS X-Ray?
Yep, I am.
Yeah. For those of you who aren't, X-Ray is basically serverless. Again, it's not the right word to say at a container camp, but it is a hosted tracing solution. And it is completely integrated here so that you can just, by adding that container into your task and setting a flag, all the traffic that goes through Envoy will also go to your tracing. So you'll have your whole mesh visualized.
So, hang on. So you're trying to tell me that you take away my infrastructure, then you take away my Kubernetes, then you take away my service mesh, and I can still have service mesh?
Yep.
Okay, so let's try to overlay this on top of our on our architecture then, and what that looks like. So if we do that, if we just overlay this on top of our existing the architecture that we saw a few slides ago, what it looks like now, each container, each task will get an Envoy sidecar. That Envoy sidecar is producing all the telemetry goodness that it does in any service mesh, like Istio or whatever. And then it is centrally connected via this app mesh thingy, so you can push out policies or traffic directions and everything, as Arjen just said. At the same time, it's generating all of that telemetry, all of that distributed tracing for you. Am I right?
Yep.
And then you're saying we can collect them in an hosted or ingest them in an hosted solution, which is Amazon X-Ray?
Yep.
That's brilliant.
It's all there. And you can also see CloudWatch on there.
Yeah.
As any other of those services, everything gets sent there anyway. So we've got that out of the box.
Yeah, brilliant. So I think from our observability pillar diagram, if you remember, so we've got the monitoring covered via the CloudWatch because AppMesh is generating all your insights. Fargate is generating on your container insights where you get all the metrics from. X-Ray is giving you the distributed tracing aspect. And logs you can hook up, again, since it is connected to CloudWatch, CloudWatch has another CloudWatch log service which all the tasks would be sending their logs to. So we've pretty much got all of our pieces of observability sorted. But I do see a Dynamo in there, and I think you can also instrument Dynamo with X-Ray?
Yeah, that's pretty simple to do.
Yeah, brilliant. That's very good. So I wouldn't mind seeing this in a demo because I know you're showing me pictures, or I'm showing the pictures, but I wouldn't mind seeing a demo of this. So shall we?
Let's have some demo time.
Demo time. Let's pray to the demo gods because it didn't work out for Ben. It should work out for us, hopefully. We have a backup video though.
But we don't need the backup video.
Cool. So this is CuddleCube. Welcome to CuddleCube. It's a retirement home for your service.
Yeah. You may have noticed, by the way, during our introductions, neither of us does any UI, UX type work. So don't judge us on the way it looks, please.
If we get some VC funding out of someone here, we will definitely hire a UI, UX engineer.
Yep.
Not Enabler, V. Sorry.
Yeah. So let's have a quick look at what we can do. So we've got the resident servers, and it looks like somebody really enjoyed our first server there
Yeah.
because they made them really happy. So, yes, not all, we know with all the privacy things going on these days, we don't just put all our servers on here. This is just the ones who are more outspoken, who like to be out there, who probably served the marketing function in the past.
Yeah, and I see you have very cleverly had a DigIO icon in there and an Innablr icon in there. That's good. But yeah, as Arjen is saying, so when we admit a server to kubectl, we definitely go through a vetting process. That's why if you're trying to register servers, they won't show up as of yet. Yeah.
Sorry if you tried to put your own pictures in there. So, but let's try feeding the server. Wow, the happiness increased a lot. I think we're not the only ones clicking here. So this is good, but obviously this is nice for servers that are in there. But what we want is, let's add a new server, shall we?
Yep, let's do that.
So we've got a recent one we ran into was Old Faithful, which is a mainframe, and it's been running for 42 years. And we like to call it the oldie one, and of course, because it's so old, it's still running Solaris. Now, this is a nice COBOL server. It was recently replaced by, unfortunately, a single Lambda function. So it needed a new home.
Yeah.
And so let's submit and, right.
Will it work?
Well, it should work, because I figured we'd build something that works.
Oh no, it failed. As if we staged it. But hey, so look, it failed, okay? What do we do? It's serverless. I can't log into a server. I can't kubectl logs as Ben was able to, and then he could see you were DDoSing a server. What do we do, Arjen?
Well, we just talked about all the things we built in. And so we can look here and see our service map. And we can actually quite clearly see where it went wrong. Obviously, it's the register API that has a problem. In fact, it has a serious problem. So let's look at some of these traces for how that works.
Wow, no. People are smashing it.
Good. Cool. So going through this is all pretty standard and clear. And you see it takes 15 seconds. It's the Dynamo. See, the Dynamo is the problem.
Oh, wow. So you're telling me from that UI, you were able to figure out that you had an issue with your database?
Yeah, unfortunately. Okay, this doesn't give us a lot of information here. It just says, okay, request context canceled, and based on, see here, it's just a timeout with the loops. So let's quickly look at the raw data instead. Let's see what kind of, so somebody's using a OnePlus. Yes, we collect all your data. So let's see if we can find out where it actually went wrong. Just quickly scroll through. There's nothing. Okay, this is just the same message from before, but maybe, here, there's a, oh, Prateek, I'm so sorry. This is the issue with the certificates in the container. I thought I'd fixed it. I'm pretty sure I deployed a new version of it, and it should have worked. Let me just have a quick look here if I can fix it. Oh, yeah.
I thought you were supposed to deploy the new version, no?
Yeah.
Okay.
I think I did a stage rollout, and yeah.
Cool.
Let's
Can
just
we fix it?
It's easy to fix.
Okay. So while Arjen is fixing it, and none of this was staged, while Arjen is fixing it, I want to highlight something very important. What we just saw, as I know Arjen said it's pretty standard, and it's because he's been doing this for ages, but have a think about it. Your application in production, user are getting an outage, or user are having bad experience. How much time does it take to figure it out with just our traditional infrastructure like your kubectl logs or log files and just your monitoring? It would have been a hell of a lot of time hopping onto each service, trying to look at logs, where was the exception, then doing correlation based on times. But just as you add this lens of observability and add distributed tracing to it, don't want to call it observability, it's fine. Just add this lens of distributed tracing to it. Arjen was able to pinpoint the service which had issues. Not only just pinpoint, also got the message what was the problem with it. If this is not groundbreaking yet, it will be soon. Because think of this. When your user has an outage, he calls you up, hey, this is the problem. Do you want to sift through all the application logs? No, I don't. I just want to know where is the problem. I fix it, I go to bed. That's what I want to do. Is it not right?
Yep. I already fixed it.
Oh, did you?
Yep. The old faithful is in our system now and can happily live.
It almost sounds scripted.
Yeah, it almost does. So obviously, we're not going to go deeper into the other thing, but we do have also the insights into the CPU users, and then if any of that is really important. But as Prateek said, usually you only use these details for figuring out what's going wrong with the user experience. And all the log files are there, and we have all of that. But based on the time, I think we'll just skip ahead to...
Yep, no, that's okay. So,
wait, it's gone. Let me...
Come on, presentation gods, whatever. Where did it go? It crashed? No, there it is. Okay, so with that demo, the key thing that we wanted to highlight is even if you take away all the servers, you take away all the tools, the underlying concepts still apply, like logging, monitoring, tracing. They're so fundamental, doesn't matter what sort of solution you're trying to implement. But I would still love to ask you, Arjen, is it all unicorn and rainbows?
Oh, no, it's not all unicorn and rainbow. In fact, this is a very accurate description of me this last weekend while I was trying to
I can vouch for that. He was on the phone with me and he's just yelling on the other end.
Yeah, if you think he swears a lot on stage, you should hear it with me.
It was fucked. I mean, it was stuffed.
Okay, so, but yeah, there were some issues. Like I said, it's very shiny, but in general, it means it can be a bit finicky to implement. And it is serverless. You can't SSH into it and figure out what's going on. You don't have all the insights and details you would have if you run it on a system where you can see the system logs and things like that. So it makes it a lot harder to debug. Also, there are some things where we just didn't think clearly. So, for example, X-Ray still needs some code instrumentation. It's not all out of the box because obviously HTTP is a stateless protocol. So to figure out how to pass on the context from one call to another, it still needed a little bit in the code. But yeah, those are the main issues.
Yeah. And I think that's pretty much sums up what we experienced over the weekend, because it's not you can't do it. It's the tools are new, and also our experience. We earned that experience. We weren't thinking clearly. But that's what we wanted to highlight. We're not trying to sell unicorns and rainbows here. You will have issues, as Arjen said. But in conclusion, what I would like to sum it up as a lot of it, we got it out of the box. Like the application stack is still running. We haven't crafted any EC2 instances or any ECS containers or ECS tasks or services, ECS clusters or Kubernetes clusters. A lot of it was out of the box. All these instrumentation, we didn't have to go and instrument each function call. What we had to make sure, though, that our plain HTTP library knew how to propagate the context. And that's a mandatory requirement for distributed tracing as well, because once an API gets a call, you need to pass on the headers to the next API call. That's how you do it in tracing, and that's what we didn't think. We were expecting everything to be out of the box. And the integration with other service was just sweet, because with Dynamo, we didn't know how we will instrument Dynamo, but this thing just did it for us. And once it is up and running, once it is set up, not setting it up, but once it is up and running and set up, you can exactly see what is going wrong. As Arjen showed you in the demo, we were able to pinpoint which service was failing. Just by looking at a page, we were able to know which service is failing. But setting it up is still a challenge. Now, last thing that I want to add to this conclusion is always take a step back when you're designing a solution, implementing a solution. Take a step back from tools. That's what Arjen did today with me. When I took a step back, I understood all I'm trying to do is do observability. I don't need to worry about those tools that I'm so used to. And it can be done in any fashion, whether you're implementing serverless architecture via containers, Lambda functions, Kubernetes, EC2 instances, physical hardware, doesn't really matter. You need to look at the concepts, you need to look at the terminology and what you actually need to do. Is that the right summation, Arjen?
That sounds about right. So
and
I think we'll leave it at that.
Yep, on that note, thank you very much.